Hi, I'm Dr. James Carter, an astrophysicist. Today, we're going to discuss what is, without question, the most baffling and fascinating object our observatories are currently tracking. It's designated 3I Atlas, the third interstellar object ever confirmed.
The trajectory problem. First, let's talk about its path. When an object comes from interstellar space, it should arrive on a random trajectory. Imagine throwing a marble across a football stadium. It could come from any angle. But 3I Atlas arrived on a path tilted just 5 degrees from the ecliptic plane. That's the flat plane our own planets orbit on. But it gets stranger. Its trajectory is bringing it unusually close to multiple planets. It already passed within 28 million kilometers of Mars on October 3rd. It's scheduled to pass Venus and later Jupiter. For example, think of a tourist arriving in a new city. A random tourist might end up anywhere. This object is like a tourist who arrives and immediately gets on the perfect scenic bus route, one that just happens to cruise past the city's 3 biggest landmarks in perfect sequence. The combined probability of this happening by chance is estimated at 1 in 20,000. It's statistically improbable.
The chemistry problem.
When we pointed the James Webb Space Telescope and the Very Large Telescope at 3I Atlas, we expected to see the chemical signature of a comet. And we did. Sort of. We saw a massive coma driven by carbon dioxide, not water. Unusual, but plausible. But then we found the real puzzle. The object is outgassing abundant atomic nickel. This isn't unheard of, but in every natural object we have ever studied, comets, asteroids, meteorites, where there is nickel, there is also iron. They are formed together in supernova explosions. They travel together through space. 3I Atlas has virtually no iron. Finding abundant nickel with no iron is, from a chemical perspective, almost impossible. It's like finding smoke without a fire. Or, to give you another analogy, it's like baking a cake and finding it's full of pure refined sugar, but with zero trace of the flour, eggs, or water you need to make it. Natural processes don't refine materials. This chemical signature looks less like a rock and more like an industrial alloy.
The mass problem.
Now, this is where it gets deeply strange. We can see 3I Atlas outgassing. We've measured it. It's ejecting about 150 kilograms of material every single second. When a comet does this, it acts like a small, unpredictable rocket engine. Picture a soda can fizzing and spinning. That thrust should push the comet, causing it to deviate from a purely gravitational path. We call this non-gravitational acceleration. The anomaly? 3I Atlas shows almost zero non-gravitational acceleration. Its path is razor-sharp, matching a purely gravitational orbit. So we have a paradox. How can an object be visibly firing its thrusters, but not be moving? The only logical answer is that the object must be extraordinarily massive. For 150 kilograms of thrust to have no effect, we calculate 3I Atlas must have a minimum mass of 33 billion tons. This is a problem. An object that massive is thousands of times heavier than other interstellar comets. Our surveys should have detected tens of thousands of smaller objects before spotting a giant like this. How could it be so massive yet so active? This data has led to some uncomfortable speculation. What if the object isn't a solid kilometer-wide rock? What if it's a hollow structure, 10 or 15 kilometers wide, with thin walls? That could account for the mass, but that, of course, isn't a natural formation.
All of this leads to what happened just days ago on October 21st. A full halo coronal mass ejection, a massive solar flare, erupted from the sun and struck 3I Atlas directly. When this happens, we expect the flare's energy to scatter, to wash over the comet. Instead, our solar observatories logged an unexplained absorption event. The energy didn't scatter, it vanished. For example, imagine a huge wave crashing against a buoy in the ocean. You'd expect a massive splash, spray everywhere. What we saw was like the wave hitting the buoy and the buoy just absorbing it, leaving the water around it eerily calm. And then, 12 hours later, orbital tracking stations confirmed it. 3I Atlas began to accelerate, not from outgassing. This was acceleration requiring energy input. It's as if it fed on the flare.
This brings us to right now. All of this is happening just as 3I Atlas approaches its perihelion, its closest point to the Sun, on October 29th. This is the single best moment for any object to perform an orbital maneuver. And here is the final remarkable coincidence. On October 29th, 3I Atlas will be in solar conjunction. It will be on the exact opposite side of the Sun from Earth. It's like a ship vanishing behind an island for 3 full weeks, precisely at the most critical moment of its journey. We won't be able to see it. We have data from the Mars flyby from NASA's HiRISE camera that could give us a clear image, but that data has not yet been released, with officials citing the ongoing government shutdown. The timing of it all is inconvenient. So what happens next? We wait. We wait for 3I Atlas to emerge from behind the Sun in November. And we will be watching for one thing. Has its orbit changed? Is it still on the hyperbolic escape path, destined to leave our solar system? Or has it used that energy to change its course? Is it staying? We are scientists. We follow the data. And right now, the data is leading us into truly uncharted territory. If this cosmic mystery intrigues you, subscribe for our updates. We will be back as soon as 3I Atlas emerges. Clear skies, everyone.